Hi students, I am Dr. G.S. Brahma, working as an associate professor in chemistry, Faculty of Science Technology, Icfai Foundation for Higher Education, a deemed university located in Hyderabad. Today my topic of presentation is chemical interactions in materials. My topic comprises of 4 sections. I will briefly discuss the introduction part. First of all, we will try to understand what is chemistry and what are materials, how the materials are formed. Then I will of course expose you to the types of material with examples, and then in the third section I will explain you what are the types of interaction that exist within the material, and during the formation of material what type of interaction take place. Then we will conclude the topic accordingly. First we need to understand that what is chemistry. Chemistry is a very old branch of science. From 15th century onwards it emerged as a branch of science which basically deals with the properties and behavior of matter. All of you know what is matter. Matter is something having physical existence and which can be used for many useful applications. So, material is the noun form of matter, and material or matter, they are nothing but compounds which are formed from, which are synthesized from atoms, molecules and ions by different type of interaction. So, chemistry deals with the composition, structure, properties, behavior of the matter, and of course, the changes the matter undergo during a reaction with other substances. Before getting into the topic, let me show you certain figures, very attractive figures. These are 6 matters, 6 chemical compounds. The first one is the tin metal. Second, the sulfur, which is amorphous solid. Tin is a metal, sulfur is a amorphous solid. Third one is a diamond crystal. Fourth one is the crystals of sugar, the sucrose that we eat in our daily food, and salt. Fourth one, sodium chloride, again the crystalline structure. Fifth one is baking soda, sodium bicarbonate, used in baking industries. These are some of the very widely used common chemical compounds, materials. So, what is chemical reaction? As I explained, chemical reaction means when atoms of 2 different elements or more than 2 elements, they combine with each other at different proportions and different fashions. That is called chemical reaction. There are different type of chemical reactions are there that I am not going to discuss here, like addition reaction, displacement reaction, electron transfer reaction. So, during chemical reaction what happens? The bonds between atoms break and form. So, there is simultaneous breaking of bonds and formation of bonds. Reactant bonds are broken, product bonds are formed. So, one substance is transformed into another substance, and remember, chemical transformation is permanent, it is not reversible. Once the reactant is converted into product, in very few cases the reversibility occurs, otherwise the product is altogether different from the reactant and it is difficult to reverse the product back into reactants. I have given you an example here. The process, the reaction that takes place inside a blast furnace in metallurgical industry, iron smelting industries, where the iron oxide, a compound, react with carbon monoxide to form the iron metal, and along with that carbon dioxide is released. So, this is a chemical process, a chemical reaction where the oxide of iron is converted into iron metal. So, how a compound is formed? As already I explained, when the atoms of two or more elements, they combine at a definite proportion that give rise to a compound. So, the combination of atoms of more than two elements that take place in different fashion, those that are called the chemical interaction or chemical bonding, that we will be discussing shortly. So, a compound contains the atoms in a fixed ratio irrespective of the source of the compound, and the atoms are held by permanent bonding with one another. So, look at this periodic table. These are the elements till now discovered or synthesized. Most of the elements are naturally occurring. So, you can see the distinguished colors, the elements that are present on the left hand side, the first group and second group, they are alkaline metals and alkaline earth metals, and the group 18 is the inert gases, helium, neon, argon, krypton, xenon, radon. And look at the element number 118, organocene, the recently discovered element. And you can, in the periodic table, if you see the metals, they are present in the left hand side, non-metals are on the right hand side, and the transition metals are present in the center. The transition metals are present at the center. Transition metals are those elements which exhibit properties intermediate between the metals and non-metals. And you can see two rows below. The first row is called the lanthanoid series and second row is called the actinide series. So, these are the elements till now identified, and scientists or chemists, they play with these elements, they combine these atoms of these elements in different proportion, in different fashion, so that a desired material is resulted. What are the materials which attracts the attention of engineers? Being an engineer, it is important to have the knowledge of chemical properties of engineering materials, because unless the engineer does not understand the properties of material, he cannot recommend this for a particular application. So, before sending the materials for application, the engineer has a thorough idea, thorough knowledge about the chemical property of the material. So, what are those chemical properties? Some of the chemical properties of engineering materials include the composition, at what proportion, on what molar proportion the different elements are combined to form the material, and atomic bonding, what is the nature of bonding exists in the material, whether it is a primary interaction or is a secondary interaction, bonding is ionic, covalent or coordinate, metallic, that he needs to understand. Then another property is corrosion resistance. The material whatever is synthesized, whether it how much tolerance power the material has for corrosion, whether it is corrosion resistant or it is vulnerable for corrosion, that he needs to understand. Then what is the acidity and alkalinity of the material? So, these are some of the basic chemical properties the engineer must know before recommending the material for application. So, what is chemical composition? The chemical composition of engineering material indicates the element which are combined together to form the material, because chemical composition of the material has a direct impact on the properties of the engineering material. For example, the strength of the material, stiffness of the material, hardness of the material, ductility of the material, resilience of the material, the corrosion resistance of the material, weldability, all that depends on the chemical composition of the materials. If the chemical composition changes, Accordingly, these mechanical properties also changes. Look at some examples of common materials used in our day-to-day application, day-to-day basis. Steel, steel contains iron, chromium and nickel at different proportion. Brass, which is an alloy, contains copper 90%, nickel 10%. Bronze, copper and tin. Then invar, iron, nickel. Gunmetal, copper, tin, zinc. Similarly, German silver contains copper, zinc, nickel. Then phosphor bronze contains copper, tin and phosphorus. Then manganese contains copper, manganese and nickel. Constantan contains copper and nickel. Please make a correction here. This bronze is copper plus zinc. So, always while synthesizing the material, a linear relationship exists among processing. What is the methodology adopted for processing the material? The processing method determines the structure of the material. Means if the same elements, for example, you are taking 3 elements and you are combining them at one proportion, it gives rise to one type of structure. If the proportion changes, then the structure of the material changes. So, it is the processing method of processing that determines the structure of the material, and the structure of the material determines the properties. And once the properties are determined, then that will decide what would be the performance of the material. So, there is a linear relationship exists among processing, structure, properties and performance. So, the engineer has a choice, has a luxury of manipulating the thing at the first level itself. If he changes the processing method, accordingly the structure will change, and once the structure changes, accordingly the property will change and performance will also change. Now, see what is the conventional method of classification of materials. Materials are classified the 4 conventional types: metals, ceramics, polymers, then composites. Then the 5th type of material is advanced material, which includes semiconductors and biomaterials. And 6th type of material is materials of future, the future generation materials containing smart materials and nanomaterials. I will give the examples of each class of material for your understanding. Before that, what are the chemical properties of engineering materials that an engineer must understand before recommending the material for a particular application? Toxicity, the oxidation state of atoms in the compound, then heat of combustion, then what is the chemical stability, what is the thermodynamic stability of the material, what is the flammability of the material, then what is the coordination number in case the material comprising of transition metal complexes, what is the reactivity, means what is the half life of a reaction the material undergoes, what are the possible chemical bonds present inside the material, what is the enthalpy of formation. So, these are some of the primary properties the engineer must understand. Then behavior and manufacturing properties of engineering materials comprises of 4 different verticals: the structure of material, physical and chemical properties, mechanical properties and the property transformation. Structure of material includes the nature of bonding present inside the material and what is the physical appearance, whether it is crystalline or it is amorphous. Then the physical and chemical properties include the melting point, the boiling point, the coefficient of thermal expansion, corrosion resistance ability, all those aspects. Mechanical properties include the strength, stiffness, ductility, elasticity, hardness, toughness, the strength, all these aspects. Then property modification, how the one set of properties exhibited by the material can be modified into a altogether different set of properties. This is accomplished by heat treatment, annealing, tampering, then mixing, all those aspects. Look at these figures. The first set of materials, they are the familiar objects made up of metals, a fork, a knife, a pair of scissors, coins, a gear, a wedding ring, and a nut and bolt. These are all examples of metals. So, what is the nature of bonding present within the atoms inside the metal? The bonding is metallic bond. Then look at the second set of materials, they are ceramic materials. You can see a plate, ceramic plate, a brick, a ceramic tile, a glass, all these are examples of ceramic materials. The type of bonding involved will be either ionic or covalent. Then the next type of material is polymers. Several common objects are made up of polymeric material, plastic tableware, a spoon, a knife, a bicycle helmet, a lawn mower wheel or a milk carton, they are made up of polymers. What is the nature of bonding in polymers? Nature of bonding is mainly covalent bonding between the carbon and carbon atom. Look at the below figure, the composites. Composites are the materials prepared from the combination of two or more materials. Example is a fiberglass. See, fiber is the material is polymer, glass is ceramics. So, it is a fiberglass is a composite, is a mixture of polymer and ceramic. And certain building materials, they are also examples of composites. Even the concrete used in construction of houses, the example of composites. The next class of materials is biomaterials. Now, you must be knowing that the medical science has made tremendous advancement, and many artificial organs are prepared, are fabricated and replaced for natural organs which has gone damaged. So, we can see a heart valve, hip replacement, knee replacement, finger joint implants, the catheters and stents, the contact lens, they are all examples of biomaterials. They are also synthesized by chemical means. The next class of materials are smart materials. As the name suggests, smart means these materials they behave very smartly. Means the material they exhibit the change in properties depending upon the outside environment. The materials used in actuators, sensors, they are examples of smart materials. Here I want to give one example. Suppose you take a temperature sensing chips. At ground level, it senses the temperature of 25 degree, 30 degree, whatever temperature is prevalent there. As you go up, the temperature decreases. If you take that temperature sensor while flying by aeroplane, and at that time if you check the temperature outside, then the temperature is minus 30 degree. So, the same chips, temperature chips can sense temperature of plus 25 degree and minus 30 degree. So, because the chip is made up of smart materials, it can shift its response, it can exhibit its response depending upon the outside surrounding. See here, smart materials used in aeroplanes, Boeing 777, the smart material used, and the piezoelectric material, example of smart material used in the rotor trailing edge flaps in the helicopter. These are examples of smart material. Another class of material which has come to prominence in recent times is the nanomaterials. Why these materials are called nanomaterials? When the molecular size is degraded, is decreased to nanoscale, nano means 10 to power minus 9 meter. When the molecular or the atomic size is reduced to nanoscale, so, and the material containing those atomic size or molecular size are called nanomaterials. They exist as nanospheres, nanotubes, nanofilms, bulk nanomaterials or polycrystalline materials. See, look at the figures here, the quantum dots used in many applications, advanced applications is example of a 0 dimensional nanomaterial. Then fullerenes, the Buckminster fullerene, carbon 60, this is called the carbon 60 Buckminster fullerene, contain 60 carbon atoms. This is isolated in the nanoscale, it has its tremendous application. Gold nanoparticles, then nanorods are used, nanotubes are used. See, these nanomaterials have found application mainly in the communication field, in the medical applications, the targeted drug delivery, etc. are the applications of nanomaterial. Now, question arises that why we are discussing this material, different classes of material. One thing you remember, irrespective of the class of materials, all of them, each one of them are synthesized by chemical interaction of atoms of different elements. Does not matter which class the material belong to, but it must have been prepared, it must have been synthesized by the chemical interaction of atoms of different elements. So, what are these chemical interactions? Basically, the chemical interactions are two types, primary interaction and secondary interaction. The primary interaction involves interatomic or interionic interaction, whereas secondary interaction involves intermolecular interaction. Now, see what are primary interaction? Primary interaction comprises of three major types: ionic interaction, metallic interaction, covalent interaction, and the fourth type, coordinate interaction, is a special case of covalent interaction. Okay. Otherwise, the mechanism is one and the same, but it is a special coordinate interaction is a special case of covalent interaction. So, very commonly we call it as ionic bond, metallic bond and covalent bond. Similarly, secondary interaction are four types. First one is hydrogen bonding, dipole-dipole interaction, otherwise called van der Waals interaction, dipole-induced dipole interaction, and induced dipole interaction called the London's dispersive force. So, this is the classification of materials, different type of classes of material that we have gone through. In the coming session, we will discuss that what are the different type of chemical interaction that exist within the material. Thank you.